Hello, and welcome to Permutations and Combinations. My name's Tuesday Johnson. Here's an introduction to some applications. We're headed to the DMV, first of all, Department of Motor Vehicles. A certain license plate allows 6 letters for display. We want to calculate the following. First of all, we want to calculate how many 6-letter sequences are possible with the English alphabet. Sequences requires a particular order. Okay, we want 6 letters. How many do we have? Well, the English alphabet at time of recording has 26 letters. So if we want sequences, we want the permutations of the 26 letters, taken 6 at a time, and this will give us 164,765,600 different license plates just using letters of the English alphabet 6 at a time, right? Distinct. As you see over here, almost no state in these displays. There are no states in these display, and this display has just letters. Frequently they'll mix it up with letters and numbers because that gives us 36 different values to work with, which gives us even more. But what if you have this certain type of memory that you always memorize things in alphabetical order, right? So you see this license plate going by, somebody's speeding through your neighborhood, you see the license plate, you take a mental picture, you see it in alphabetical order instead of the order that it is given. Well, is it worth telling the police about what you saw? How many 6-letter sets are possible with the English alphabet? We still have 26 letters. We still want 6. But this time we're looking for a set. Alright? A set, not a sequence. So we'll look at combinations. Combinations deal with sets of items. Permutations deal with sequences. Well, the number of combinations of 26 letters taken 6 at a time is 230,230. So even if you remember most of the letters, you're still helping out and narrowing things down by a wide margin. So be a good witness or keep your mouth shut. Depends on your values there. Alright, example 2, traveling the world. As a graduation gift to yourself, you're traveling to the 5 locations of your dreams. You want to go to Hawaii, Fiji, the Bahamas, Bali, and the Canary Isles. How many possible itineraries are there? Well, an itinerary is an ordered listing of your trip or your plans. So if it's in order, right, we have 5 options for our first location, and then 4 remaining, and then 3, and so on. So it turns out that there are 5 factorial, or 120, different itineraries to go to these 5 different islands. Really, that would be probably the best math problem to test out, right? Let's see if we can make 120 different vacations. Let me just get on that billion-dollar lottery winnings here. So 120 different ways to create our adventure. Fantastic. But if you must start in Bali for your brother's wedding, how many possible itineraries are there? Well, you start in Bali, so we'll just take that out. After you're there, you have 4, and then 3, and then 2, and then 1 option. And we multiply those to get 24. These are just straight up permutations, right? Permutations of 5 islands. Permutations of 4 islands. So if you get to go to the islands in whatever order you would like, you have 120 choices. If you show up in Bali first for your brother's wedding and do the right thing, hang out, celebrate, there's 24 different ways that you could finish your trip. Alright, permutations. Let's go to the movies. Your math professor is giving you a weekend with no homework. To celebrate, you and your friends are going to have a movie marathon. You want to pick 3 movies to watch on Saturday from the list of all-time highest grossing films. How many sets of 3 movies are there? Well, we have the 10 highest ranking movies of all time. We want 3. We want sets, so we'll use the combinations of 10 movies taken 3 at a time, which will give us 120 different sets of 3 movies that we could watch. Okay. Next, Shannon refuses to watch a Marvel movie. How many groups will satisfy Shannon? Well, there's a couple of things we have to check out first. First of all, how many movies are not Marvel movies? And if you're not sure, there's 1, 2, 3, 4, 5, 6 movies that are not officially associated with the Marvel Cinematic Universe, MCU, I think is what it is. So there are 6 possible if Shannon's going to be in the group, and you still want to watch 3. We're looking for sets, right? Just groups. So there's 20 different movie marathons you can have if you want to keep Shannon around. She seems like a pretty cool person, so we'd probably keep her. So you want to pick 3 movies, blah, blah, blah. Now, Shannon not only refuses to watch a Marvel movie, but she insists on watching either Avatar or Titanic. How many groups will satisfy Shannon? I'm guessing only her friend group. But I mean, how many groups of movies will satisfy Shannon here? So, we can write a decision algorithm for this. Okay, so she wants Avatar or Titanic. But keep in mind, in math, or is not just either or. It's either or, it's one or the other or both. So in our decision algorithm, alternative 1, we only watch one of Avatar or Titanic. So our first step will be to choose one out of Avatar or Titanic. So that's the combinations of the 2 movies. Choose one, which gives us an answer of 2. Now we have 4 movies remaining, right? Avatar and Titanic are not there. There's the other 4 movies that are not Marvel. So we want to choose 2, right? So we want a total of 3 movies. 1 has to be either Avatar or Titanic, and then 2 from the others, 4, 2. Combinations of 4 items taken 2 at a time is 6. But what happens if we watch both Avatar and Titanic? Step 1, we'll choose 2 out of those 2 movies. So the combinations of 2, 2 is equal to 1. If I want to choose both, there's only one way I could do it. I choose both. And then we'll want 1 more movie, because we want our group of 3. Right? Choose 1 out of the remaining 4 available. 4, 1 of combinations will give us 4. Notice each time the 2 and the 4, the leading numbers of what we have, make our total of 6 movies that we're looking at. The 1 and the 2 in the second position here, in the R spot, that makes up the total of 3 that we want to have. 2 and 4 make 6 total movies that we're looking at. 2 and 1 makes 3 movies that we're picking for the marathon. If we put this together, remember, in steps we multiply. Combinations of 2, 1 times the combinations of 4, 2. But in alternatives, we add. So then we'll add, so or, the combinations of 2, 2 times the combinations of 4, 1. Substituting our numbers, we'll have 2 times 6 plus 1 times 4, which is 12 plus 4, or 16 different movie marathons. So even if your friends seem a little picky or something, unless you really had your heart set on Marvel, it's okay. You still have plenty of options for making a movie marathon. It doesn't hurt to help people out with what they like sometimes. Who am I kidding? I'd probably just put in a Marvel one and make her decide. I'm kind of a jerk, but I'm a nice jerk. Thanks for watching, and be sure to subscribe to Math with Tuesday on YouTube, because you never know what I'm going to say during a video.